So a little bit about site characterization. These are soil borings in terms of what's going on in terms of what we're really concerned about. Looking for any type of waste materials based on potential contamination and that type of thing. Essentially, what you have here too, have your casing in here. Again, you have that a little bit of a mound here. These are just the typical for unconsolidated soils and that type of thing. And we're basically monitoring well to see what where this stuff is going, okay, the possible contamination. Then you have for bedrock conditions, okay, same type of thing. Here's your water table in here. They penetrate that. So essentially what you have back here, this is what unconsolidated soil, excuse me, frog in my throat. Can be, can be fractured, okay, and could be weathered bedrock and that type of thing. So we're trying to get an idea. This is with bedrock conditions. And what we do is we ask them, essentially what we do is we're going to, we're taking the soil samples here, what they call from the cuttings, okay? We're going to have a auger that gets into to collect the sample. Essentially, if you look at the volume of the sample, again, it's cylindrical, that type of thing. Basically the sum of it, the height of it here. Here's your diameter, here's your height, and some type of an expansion factor based on what the material is looking like, okay? So D is the diameter of the borehole, okay, and H is the depth of it. The expansion factor essentially is typically between about 1.1 and 1.3, basically the density, and because you disturb it, thinking like anybody ever take a drill and do it into a piece of wood, it's consolidated, okay, before you drill it, okay, when it comes out of it, it's unconsolidated. You have basically air gaps and that type of thing. That's essentially the difference in that. And typically for soils, you got an expansion factor of about 1.1 to 1.3. So determine on the number of 55-gallon drums necessary to containerize soil cuttings from 8 soil borings using a 6-inch auger outside diameter, okay, to a depth of 35 feet below grade. Assuming an expansion factor of 1.3. So we're pretty straightforward on this. Calculate the volume of the soil borings, okay. 6-inch side, okay. Soil overall volume, okay, was 35 feet. Expansion factor, 6 inches in a foot, 12 inches in a foot. But you just do a conversion factor in here because we want this in feet. So what that gives is for 35 feet, 6-inch bore, we're going to end up with about a little under 9 cubic feet of soil, assuming that this is an expanded factor, right? Next, we're going to calculate the total volume of the soil for all the borings, okay? We had 8 soil borings that we had. Essentially what we got here too is about 9 cubic foot per boring. Got 7.48 gallons per cubic foot. Good old number. Did you remember that number, Lori, for your exam? Was that water and wastewater stuff? 7.48 gallons per cubic foot. 8 soil borings. So we're just converting this into gallons because we want to put them into 55-gallon drums. So that turns out to be about 533 gallons. Okay. So the number of 55-gallon drums essentially turns out to be about 9.69 or about 10 drums. Pretty straightforward calculation.